Okay, so the first thing that we want to do whenever we're looking at these problems is to look at the equations that we have access to. So for this specific lesson, we are focused on this equation, okay, which involves volume and temperature. And we also have this conversion from our last unit that is useful as well. So the first thing you want to do whenever you see these problems is look for all of the degrees Celsius. So here we have one value that is degrees Celsius, and we want to go ahead and just convert that to kelvins. So I'm going to do that by just adding 273 to this value of 67, and we get 340 kelvins. Okay. All right, so now we're ready to go. So these are the variables that we're working with. So I want to identify what my variables are. So just kind of off to the side, I'm going to write volume 1 equals, temperature 1 equals, volume 2 equals, and temperature 2 equals. And then I'm going to read through my problem. So a sample of air has a volume of 140 milliliters at 340 kelvins. So just from reading comprehension, I know that those two numbers go together. So I'm going to label those as my initial condition. So volume 1 and temperature 1. So we have 140 milliliters and 340 kelvins. The next sentence says, at what temperature, so that's a massive clue that we're solving for T2, at what temperature will its volume be 50 milliliters at constant pressure? So our volume 2 is 50 milliliters. And now we can solve. So again, I'm using this equation here, and the first thing I want to do is just copy it down. So V1 over T1 is equal to V2 over T2. And I'm solving for T2. So I want to isolate T2 first, and I'm going to use the method of moving the equation around and then solving. So what I'm going to do is I'm going to cross multiply. So just to get rid of my fractions, V1 and T2 is equal to T1 and V. Oops. So we now have our equation V1 times T2 is equal to T1 times V2. So we want to get T2 by itself. So to do that, I want to move V1 over to the other side. So I'm going to do that by dividing. V1 cancels out, and then I can rewrite my equation to be T2 is equal to T1 V2 divided by V1. From here, I can just plug in my values. So T2 is equal to T1, which is 340 kelvins, multiplied by V2, which is 50 milliliters, divided by V1, which is 140 milliliters. Since we have milliliters in the top and in the numerator and in the denominator, we can cancel those out. And as you're solving for this, my suggestion is to always just go slowly with the calculator. So to solve for this, I'm going to do 340 times 50 and then hit the equal button. And then I'm going to divide that by 140. Okay. And in this class, we always want to round to the hundredth, which is 2 decimal points or 2 places after the decimal point. So our answer is 121.43, and our unit that we have is kelvins. That's our answer.